Hello everyone, how are you all? I hope all of you are doing very well. Welcome to my channel, that is Homeschooling with SciMa. This video is about one of the questions in triangle. I will tell you how a congruency is proved in a triangle chapter. Okay, so this chapter is full of congruency, proving of congruency and CPCT. Okay, if you have watched my previous videos, if you have not watched my previous videos, please go back and watch my videos so that you will get an idea what I'm talking about. I'll be solving one question and with the steps, okay, how to solve how to prove a congruency between the triangle using different steps. Okay, so this is very important, whether it's a 2-marker or a 3-marker or a 4-marker questions. You have to understand what steps we have to follow, what is a step, what is a procedure to write a particular proving sum. All right, so let's get started with the video. So I am doing a how is it done series. Okay, I have done one question on this series. Okay, I've solved one question and which help you, which gives you some idea on how to prove a congruency. Okay, this is the second question which I'll be doing for you. So let's get started with this. So this question is asking, here the figure is given. This question asks, AB is a line segment, P and Q are points on opposite sides. Okay, so AB, you can see here AB is a line segment and P and Q are points on P and Q are on opposite sides of AB and they are equidistant from AB. That means AQ is equal to BQ. Q is equidistant from AB. Similarly, P is also equidistant from AB. That means AP is equal to PB, as you can see in the figure. Okay, you have to show that PQ is the perpendicular bisector of AB. So PQ you have to show as perpendicular bisector of AB, meaning you have to show this angle to be 90 degree. Okay, perpendicular bisector, how we can show? Perpendicular bisectors always make 90 degree. Okay, so if you have to show PQ is a perpendicular bisector of AB, basically you have to show this angle to be 90. Okay, so this is how. So this is how is the question given to us. Okay, first you need to read the question calmly. Okay, you should understand what is given. So I told you in my previous video what are the steps we have to write. So our first step will be, so step 1 will be, step 1 will be to write what is given. Okay, so what is given here? Here what is given? AQ is equal to BQ and AP is equal to PB. These are the two things which are given to us once we read the question. Okay, and after that step 2 will be, step 2 is to write what you need to prove. So what you need to prove here, PQ is the perpendicular bisector of AB. Okay, this is a symbol we use for perpendicular. Okay, so you have to prove PQ is a perpendicular bisector of AB or not. Basically you have to prove angle you have to prove angle PCB equal to angle PCA 90 degree. Okay, you have to prove 90 degree angle. So how do we do it? Now third step should be, third step we have to use. Now what would be the third step? Third step will be proving. How do we prove? Proof. Okay, so how do we go about proving this sum, this question? So first is we need to identify which congruency rule we will apply here. Okay, so first I am taking the triangle here. So first I take triangle PAQ and triangle PBQ. Okay, I am taking this whole big triangle and this triangle. Okay, as you can see in the figure. So PAQ and PBQ I have taken the triangle. I can draw it for you again here and explain you. Okay, so I am taking these two triangles. Alright, this is C. Now once I take this triangle, I am going to prove the congruency between these two triangles. So here I can see what is given to us. AP is equal to PB. These two sides are given to us. This is given. Then AQ is equal to BQ, also given. Right? And one more thing, what is given here? Between these two triangles, you can see here PQ. PQ is equal to QP. It is a common side. Okay, it's a common side. PQ is a common side to this triangle PAQ, as well as PQ is the side belonging to triangle PBQ. So we can write common side. Therefore, I can say now which rule applies here? SSS. Right? All the three sides. So the three sides of triangle PAQ is equal to the corresponding three sides of the triangle PBQ. Okay, so therefore I can say triangle PAQ is congruent to triangle PBQ. Okay, by SSS rule. All right, why I did this congruency? Now I can say, hence I can say this angle APQ. Hence angle APQ is equal to angle BPQ by CPCT. Right? Once we have done the congruency, I can say the corresponding angles of the congruent triangle are equal. I can prove this to be equal. Now why I did this? Why I did this is because I need to prove congruency between these two triangles. Now for proving congruency between these two triangles, I wanted these two angles to be equal. Okay, so let's see how do we do the congruency between these two triangles now. All right, so now I will take triangle. In triangle, as you can see here, it is APC. In triangle APC and triangle BPC. All right, so here what do we take now? What is given to us? We'll see here. See here, PA is equal to PB is given, already given. Okay, here already it's given. This side is equal to this side is already given, which we used even here also, right? We can use that. Then we can write this part. Angle APQ is equal to angle BPQ. Now Q, we will not write Q, we can write C here. Okay, because Q now it will not belong to this triangle, so we can write only C. APC I can write here, right? So I can write here angle APC equal to angle BPC. Okay, this is also we proved already. Okay, now if you see the figure PC, now here if you see PC, this PC is the common side. Okay, now PC I can write equal to CP, which is the common side. Now children, you can understand. Now students, can you tell me which rule we can apply here? This is S, A and S. Okay, so therefore triangle APC is congruent to triangle BPC by which rule? By SAS rule. Alright, so why we did the congruency between these two triangles, now we will understand. Now there is a purpose, right? Simply we are not doing the congruency. Now between these two triangles I got the congruency. Now I can say that these two angles, now this angle belongs to triangle APC and this triangle belongs to triangle BPC. Now I can say these two angles are equal by CPCT. Understand? We proved the congruency. Now I can write the corresponding angles to be equal by CPCT. So hence we can write angle PCA is equal to angle PCB by CPCT. Okay, so if you see this triangle angle, I have written angle PCA is equal to angle PCB. Okay, after this, now what we have to do after this? Now this triangle we got, it was something like this, right? PCA. We proved these two triangles to be equal by CPCT. Now we can write angle PCA plus angle PCB. Now it is sum is 180 degree, right? Because it forms a straight line. They are linear pairs. They are linear pairs. Okay. So once they are equal, I can write it as twice angle PCA is equal to 180 degree. Okay. So after that, so twice of angle PCA is equal to 180 degree. So angle PCA will be equal to 180 by 2. Okay. So 180 by 2 will be 90 degree. So we got this angle PCA 90 degree. Obviously angle 2, other angle also will be 90 degree because they both are equal angles, right? So this also we got 90, this also we got 90. So what I told you, what they are asking us to prove that PQ is a perpendicular bisector. I told you initially that we have to prove this angle to be 90 degree. When it is 90 degree, it means that it is bisecting perpendicularly. It is perpendicularly bisecting the line AB. So PQ is perpendicular bisector. So our main aim was to prove this angle to be 90 degree. Okay. How did we prove? By congruency, and after that CPCT. Okay. So after that we can write, therefore we can say PQ is a perpendicular bisector of AB. Got it? So this is a very good question, very important question also, which involves two congruency steps. Okay, so I hope you understood this question. You practice this question, I'm sure you will understand it better. If you found this video useful, please subscribe to my channel. I'll be coming up with more videos and more questions on triangles. Till then, see you. Bye bye.